Yesterday we learned how to create equivalent fractions, so today we're going to build off that knowledge and use it to learn how to compare fractions using less than, greater than, and equal to. Let's take a look at this first example. 1/4 compared to 3/4. I went ahead and drew a picture for each of the fractions so you have a visual representation of what they look like. 1/4 has one of the 4 boxes shaded in, and 3/4 will have 3 out of the 4 boxes shaded in. Now, when you're comparing fractions with the same denominator, it's a lot easier to compare the two because all you have to do is look at the numerator to see which one is bigger and smaller. So by taking a look at the two numerators and the pictures, it's clear to see that 1/4 is less than 3/4. So I'm going to go ahead and write in less than to show that 1/4 is less than 3/4. However, when you're comparing fractions and the denominators are not the same, you can't use the same strategy of simply looking at the numerator. It involves a few extra steps. So how do you compare two fractions when the denominators are not the same? Let's take a look at this example, 4/6 compared to 2/5. You can see that the denominators are not the same, so again, we can't use the same strategy we did in the first problem. This is where our practice of creating equivalent fractions comes in. However, we can't just create any equivalent fraction. We have to create an equivalent fraction for each of the fractions so that they will share the same denominator. So, as we learned yesterday, the first step to create an equivalent fraction is to write out the multiples of the denominators. So let's start with 6. We have 6, 12, 18, 24, and 30. With 5, 10, 15, 20, 25, and 30. Since both of these fractions need to have the same denominator, we're going to look through our list of multiples to see which number they have in common. And so as we do that, we'll see that 30 is the first number that is a multiple of both 6 and 5. So we're going to use 30 as our new numerator, or denominator, excuse me. As a part of the next step to creating equivalent fractions, we now need to find out how we got from 6 to 30. So since the number is getting larger, we know that we need to multiply. So we ask ourselves, 6 times what number will give us 30? We know that 6 times 5 will give us 30. And so whatever we do to the bottom, we always have to do the top. So since we multiply the denominator times 5, we also need to multiply the numerator times 5 as well. So 4 times 5 will give us 20. And now we need to apply the same to this fraction 2/5. 5 times what number will give us 30? And we know from our multiplication facts that 5 times 6 will give us 30. And again, whatever we do to the denominator, we also need to do to the numerator. So 2 times 6 gives us 12. So now we have two equivalent fractions that represent our original fractions. 20 over 30, which represents our 4/6, and 12 over 30, which represents our 2/5. Now, looking at the denominators, we can see that they are both the same. So we can apply what we learned from that first problem and just look at our numerators. And when we do that, we can compare, and we know that 20 is greater than 12, which shows that 20/30 is greater than 12/30, or 4/6 is greater than 2/5. So that is how you compare fractions with different denominators. But if you can keep a secret, I have a little trick that can be used to help compare both types of fractions. I'm going to use the same example from the previous problem so you can see how the solutions will come out the same. In this strategy, you simply multiply the denominator of one fraction by the numerator of the other. So 6 times 2 is 12. We're going to write a little 12 above the 2/5 as a middle note. And this 12 is going to represent the fraction 2/5. And so now we do the same thing to the other side. Multiply this denominator by this numerator. 5 times 4 will give us 20. And again, this 20 is going to represent the 4/6. So now all we need to do is compare the two numbers that we have, 20 and 12. And since 20 is greater than 12, we're going to write our greater than sign, which shows that 20 is greater than 12, or 4/6 is greater than 2/5, seeing as we said that 20 was representing the 4/6 and the 12 was representing the 2/5. And that supports our original findings of 4/6 being greater than 2/5. Now, I don't want you to fully rely on this method, but it's a good way to check your work. So with that being said, now it's your turn. I want you to give these practice problems a try, and we'll go over them in class tomorrow. Good luck, and see you then.